All right, second example of chain rule, but notice this time instead of starting at 1 and stopping at some value of x, we're stopping at some value of x squared. So real quickly, let's try and remember our fundamental theorem of calculus says that if we take the derivative of the integral something that looks like this. This is just a real quick example. Fundamental theorem says that this is going to become x squared plus x. Okay? But the difference between these two problems is the x is the upper limit of integration, and the x squared right here is the upper limit of integration. So what we're going to do is we're going to make a substitution with u, and this is really similar to the chain rule that we used in the first semester. So what we're going to say is that u is going to be equal to x squared, and that du dx is going to be equal to 2x. So we're going to work with the integral from 1 to u of cosine t dt. But now what we're going to work with here is the chain rule issue. And so if I change this u up here, I can't have dy dx. Remember that dy dx, if we go all the way back to chain rule, and chain rule is a little tricky, but dy dx is going to be the same thing as dy du times du dx. So what we have to work in then is this du dx and the dy du. And so the dy du is this part, the du dx is this part. So what we're going to do is we're just going to say, hey, this guy, d dx of this, okay, times du dx. And this should be d dy. d dy of all our u's times du dx. Well, we can do this guy. This is just going to be cosine of u, and then times du dx, which is going to be 2x. And so when we finish this problem up, we just replace our u with what we set it equal to. So this is going to be cosine x squared times 2x, or 2x cosine x squared. And that x squared is inside the cosine. It's part of the whole cosine process. So there you go. Chain rule with fundamental theorem.